Hello everyone and welcome back. I am Mr. Cobalt, and in this video we're going to go over a problem involving collecting gas over water. And so this will be the first of a couple of practice problems. So in the case of when you're collecting a gas over water, you have to be concerned about water vapor that comes along with the gas. So this is, again, we're talking about the mixture of gases. One of those gases is actually water vapor, especially if you're collecting a gas over water. So what you're going to be doing, excuse me. So what you need to do is pay attention to Dalton's law of partial pressures. So the total pressure of whatever you collected is going to include the pressure due to the water vapor. So you got to subtract that out. And usually there's a table where it tells you what the partial pressure of the oxygen is at that particular pressure, right? So you would have to look it up in the table, and then you would subtract that out from the total pressure that they gave you, and then what's left over is the partial pressure of the gas you are collecting, and then you can use that to with further calculations like plugging into ideal gas law to find the partial pressure or the number of moles of the gas there. So that's the first thing we need to do is we need to find out what the partial pressure due to the oxygen is. So let's read the question. It says, in order to determine the rate of photosynthesis, the oxygen gas emitted from an aquatic plant is collected over water at a temperature of 293 Kelvin and a total pressure of 755.2 millimeters of mercury. Over a specific time period, a total of 1.02 liters of gas is collected. What mass of oxygen gas in grams forms? So we have these volume of gas. Again, the volume is going to contain both water vapor and oxygen. They give us the total pressure collected, so that's going to be the pressure of both oxygen and water vapor. So we're going to need to find the partial pressure due to water vapor, and there you need to look in a table. So in the table, at since this is the table is going to be in degrees Celsius, and so this is 293. So if you subtract out, so 293 Kelvin minus 273 Kelvin gives you 20 degrees Celsius. So you look on the table for 20 degrees Celsius, right? So at 20 degrees Celsius on my table, it says that the partial pressure of water vapor is 17.55. So 17.55 is the water vapor pressure. So I'm going to take 755.2 millimeters of mercury, and I'm subtract out, this is the total, and I'm going to subtract out the millimeters of mercury due to water. What did I say? I said 17.55. So 17.55 millimeters of mercury. Okay, so I subtract that out. Let me get my calculator. So 755.2 minus 17.55 equals, and that gives me 737.65 millimeters mercury. So that is the partial pressure of oxygen. Okay, so let's keep track of sig figs. So I have, since I'm subtracted, I'm looking at decimal places, so least number decimal places. So I have 2 decimal places here, 1, so the least number is 1, so 6 is my last digit. I'll keep the 5 because I need to do more calculations. So now that I have the partial pressure due to oxygen, now I can use the ideal gas law to find the number of moles, but I have to first convert millimeters of mercury to atmosphere. So 737.65 millimeters mercury over 1. Again, it's 760 millimeters mercury to 1 atmosphere, so 760 millimeters mercury on the bottom, 1 atmosphere on the top. So millimeters of mercury cancel out, and then I'll do my calculation. So divided by 760 equals, so we get 0.97059. So 0.9, what did I say? 7059. 7059. Okay, let's add a 2 there too. All right, so there is no atmospheres. So let me keep track of sig figs. So remember, this is an exact relationship, so I can ignore that. And then for this, remember, I only am allowed up to the 6, so the 6 is the last sig fig. So 4 sig figs is what I'm allowed. 1, 2, 3, 4. So the 5 is the last sig fig there. But I'm going to keep the rest because I'm going to do more calculations. So now I'm going to use my ideal gas law to find moles. So PV equals nRT. So if I'm solving for moles, then moles is equal to PV over RT. So now I plug everything in to find the number of moles. So the number of moles of O2 is equal to the pressure, which is 0.970592 atmospheres multiplied by the volume. The volume is 1.02 liters over R is 0.08206 liter atmospheres over mole Kelvin. And then I'm going to multiply by temperature, which is 293. Or I'm sorry, 293. 293 Kelvin. So Kelvin cancels out, liters cancels out, atmospheres cancel out, and I'm left with moles. So moles is what I want. So I'm going to calculate the number of moles. So times 1.02 divided by 0.08206 divided by 293 equals, and I get 0.0411, 0.0411, and then like 539. So 539. Okay, so that's what my calculator gives me. And again, I have to keep track of my sig figs. So I was only allowed up to the 5 here, so underline that. So I have 4 sig figs here, I have 3 here, 3 here, and I have 4 there. So the least number is 3, so I'm only allowed up to the 1. Okay, so this is moles of oxygen. Okay, so moles of oxygen, but they want mass in grams. So now I have to take the moles of oxygen, use the molar mass to convert to grams. So I'm going to use the molar mass. So I have 0.0411759 moles of oxygen over 1. The molar mass of O2 is 16, or 32, sorry, 16 times 2. So 32.00 grams of oxygen under 1 mole of oxygen. Oops. I want the moles to cancel out, so moles needs to be on the bottom. So 1 mole of oxygen and 32.00 grams of oxygen on top. So moles cancel out. And so now I do my calculation. So I'm going to multiply the moles by 32.00 equals, and I get 1.3176. 1.3176 grams of oxygen. But now I have to check my sig figs again. So again, I'm only allowed up to the 1 here. So here I have 3 sig figs. Here I have 4, so the least number is 3. So I'm going to cut it off after the 1. So I have a 7 here, so that has to go up to a 2. So the final answer is 1.32 grams of oxygen. So that's the number of grams of oxygen. And that's how you use Dalton's law. So you use Dalton's law of partial pressures to find the partial pressure of oxygen. And then from there, it was just converting to atmospheres and then putting it into the ideal gas law to find moles of the oxygen. And then you use your molar mass to convert to grams. I hope this was helpful. If you like this video, like it, share it with your friends, subscribe to the channel, make a comment in the comment section. Tell me what you think, and ring the notification bell so that way you can get more videos from me. Thanks for joining me, and I'll see you next time.